makes it a
No,
solution.
it's really just graphing, isn't it?
Yep,
Right?
that's it.
Yeah, no, it's not bad.
All right. Why don't you graph the next one, and I'll snip it in after you kind of say tell me what you see when you graph it.
Okay. I'm not sure if they intersect.
Yeah, so the graph that I have here, and the way you decide is does it look like when they're closest together, it's kind of right where my cursor is, and then it seems like they actually get further apart. So these do not intersect, and that is possible that they um yes, these would have no solution, I guess is the short of it. So in terms of what's possible, one solution, two solution, three solution kind of thing.
Okay.
All right, next one, same kind of situation. Go ahead and just graph it. Actually don't know if these, yeah, this one actually also kind of like 8. So sometimes you have none, 0, 2. Just take a look at that. What do you see here, or what do you got on your side?
So from what I can understand, they touch it 1 point on the
Yeah,
graph.
it's
Or no,
actually, yeah,
2.
one
Yeah,
point. It's
no.
actually called a tangent line. You learn more about that in calculus. It only hits in one place.
Okay.
All right, so the next one here, 10. All right, so for sure, I want you to graph this one and tell me what you see.
And then what I'm doing is right. So I would like complete the square, do the quad.
Oh, no. I just want you to go to graph them in Desmos. Just you
Oh,
graph them and tell me what
okay.
you see, just to see, hopefully you're comfortable graphing. I mean, I do this all the time. I want to make sure you've got the same capabilities I do for this.
Yeah, I can then put it into Desmos. So I'm just like, I'm kind of confused how I would solve the first one, like how I would know how to graph it.
Well, that's maybe a question for your teacher, because that the graphing is a ton of work, and to find the intersections a ton of work. Typically, what you do is you solve them through substitution, and then you make a graph that represents the intersection of the two.
Oh, so you would solve by substitution and
Yes.
then plug it back and then plug it back in for your Y value.
Right, and that gives you the ordered pairs, and then you would sort of make some graphs that go through those points.
You could also put it in vertex form. So would you also put it in vertex form to find the vertex?
Not necessarily. I mean, you can. It depends on how accurate you want your graphs to be. Usually they want you to use a tool. Usually it's your calculator, or now because this app is so good, they want you to use something else besides doing it by hand.
I'm assuming it says solve by graph. Solve the system by graphing. Yeah.
Yeah. So, but what I was asking for 10 here is just to make a graph. Tell me what you see. If you want to solve by hand, you can. I think we're going to do that in, starting in number, 13.
Okay, then yeah. Intersects two places.
All right. Yeah, I agree. And that's, you can snip. One of the nice things about the tool is you can click on the intersection points and it gives it to you. So while I'm grabbing this graph for the notes, why don't you try the next one? Do the same thing, please.
Okay. It's still two solutions.
Yep. And last one here, at least for this part.
I got two solutions for that one as well.
Yep. So you've seen the possibilities. You can either have none, one, or two. That's it. There's no other possibilities besides that. So you may want to go into the classroom and ask, like if we were to do one of these, we would find the vertex, we'd make a table, and then we'd graph the line, and we hope we'd graph it well enough to find the two places of intersection. That's our best path to doing this by hand. But maybe ask your teacher, hey, do we really need to do this by hand? We have to do a bunch by hand. Couldn't tell you.
Okay.
All right. Let's look at 13. Is that next? I don't remember what you sent me. Look at the chat here. Yeah, 7 through 12, 14. So if we're starting at 14 through 26 even. Yes, 14. All right, number 14 here. So while linear systems you often solve with elimination, most nonlinear systems, and that's what you have here, these are solved by substitution. So what that means is you're going to take one equation and put it in for the other. Like in this case, you can put 6x plus 3 in for y.
Okay.
So this becomes 6x plus 3 equals minus 3x squared. And now it looks like a problem you've been doing for months now, which is like, how do you solve a quadratic equation? So you have to decide, okay, I'm going to factor, I'm going to, bring it over, I'm going to complete the square, I'm going to, do something else, right? That's what you have to decide here. I would recommend moving the 3x squared left. So that's 3x squared plus 6x plus 3 equals 0. And then the first type of factor you always try is GCF.
Okay. And you get x squared plus 2x plus 1 equals 0.
This one does factor. It's a good chance for you to remember your factoring.
Should be 2 and -1. So x minus 1. Wait, no.
They've got to both be positive.
Yeah, so x plus 1, x minus 1.
They have to both be
Oh, yeah,
positive.
both be positive. And you get -1, -1 for your solutions.
Right. So x is -1.
Yeah.
And then if you go back, you can use either equation. Doesn't matter which one. You can use either equation to find the value of y.
-1 is 1 squared times -3, so y equals -3.
Yes, y equals -3.
And then
And
you
there's
should always go back and check it, right, to make sure it works.
You should. I mean, if you have an infinite amount of time, you would.
This
Yeah.
one does work.
Yeah. So this only has one solution. That's why you only have one x value. Why don't you try a 16 on your own and let me know what you come up with.
Okay. 16.
Yeah, you said to do evens, 14 to 26 even. Is that right?
Yep. Okay. X squared plus 2x plus 11 equals 0. I'm gonna do completing the square. X plus 1 squared equals 11 plus 1 is 12. So this is two solutions. I got x equals wait. X equals 1 plus minus 2 times the square root of 3.
This works out nicely.
Does it?
Yeah. So when you substitute, it's 2x plus 4 equals minus x squared plus 7. You move
Oh, wait,
everything
that
left.
should be, so it should be 4 minus 7. Wait, I did my math wrong. 2x, then it'd be minus 3 equals 0. So then multiply to -3, but add to 2. 3 and -1, so x minus 3. X plus 3, x minus 1. So is it x equals -3 and 1?
Yes, x is -3
And
and -1. So you have to do it for both. You have to say, okay, like let x equal -3, and then you figure out the y value. You can use either equation. I'd probably use the second one here, which ends up being -2.
-2.
Yeah, and then same thing, you let x equal
I
-1.
said there. Oh, because this is one where there's two solutions.
Yes.
Two solutions. So then it's 2. So then you'd have 1, 2.
Yes. I'm sorry, y is no, x is +1. Maybe I let you talk me into that. So the factoring here is x plus 3
X minus 1.
Yeah,
So you
so
get -3, 1.
yes, +1, and then y is 6. 2 times 1 plus 4.
Oh. Oh, yeah. Okay. Okay.
All right, well, let's have you try the next one, 18, because hey, practice makes permanent. So let's get this one right. The second equation, you need to manipulate a little bit, like you need to move the 4x over. It's 4x plus 2.
4x plus 2.
And so that's going to go in here. So try this one out. I will tell you if the answers are not nice. So expect them to be nice, at least for the time being.
Expect them to be nice or do not?
Yeah, because I don't think this one's weird. Actually, this one's got one. It's got one decimal answer. It's not really a big deal. The other one's fine. Yeah. So this kind of works nice. It's not square roots. It's not anything that crazy, but it's
Okay. I definitely did something wrong.
okay. Let's take a look here. So it's 4x plus 2 equals 2x squared plus 3x minus 4. So this time I'm going to move right because I really want to leave that 2x squared positive. So we've got 2x squared minus x minus 6 equals 0. Does this look like what you have, or do you have something different?
I got negative 2x squared plus x plus 6.
Okay, that does work. That really does work. I would strongly urge you to never have negative leading coefficients for factoring. So you can multiply everything by a -1 and get to this. Like you moved everything left, which is fine. But if you do that and it's negative, multiply everything by -1 to make it positive. So now you take this 2 and multiply by a -6. So that's -12. And you're looking for two numbers that multiply to -12 but add to -1.
Okay.
So what would that be? What gets you back to
Um, mm, -4 and 3.
okay, good. So it's 2x squared minus 4x plus 3x minus 6. And from here you use grouping. What would you factor out of the first two?
2. So then
More
it'd
than two, a little
be
more, 2x.
2x.
Yep.
You get x minus what? Or x minus 2.
Yep. And then x minus 2.
Factor out 3.
3. Yeah. So it becomes 2x plus 3, x minus 2.
So you get 2 and -3/2.
Yep. Those are correct. Now the work's not done, but it's mostly done. You got to go back and use this other equation to find y. So I would use that second equation. Give me the y values, please, whenever you got them.
Uh, 210 and
Got it?
210 and -3/2 and -4.
You got it. Good. Okay. Do you feel like you better understand the method of substitution?
Yeah.
Okay. So on to elimination. All right. And this is odd. I actually don't teach this approach because I don't think it's very useful. But we can do it. It's just that it's like, what are we doing? All right. So if you recall, like one of the key things when you're eliminating is that you're either adding or subtracting the equations, and you sometimes multiply one equation or the other or both by a number. Does that sound familiar to you?
Yeah.
Okay, so here's what I'm doing. I'm just rewriting the equation, kind of lining stuff up. And we're going to subtract the second equation from the first equation. Okay, so y minus y is 0. We've got 0 there. Bring down the minus 3x squared. X minus x is 0. 2 minus 4 is minus 2. Is that okay?
Yeah.
All right.
Add 2.
Add 2, divide by -3, and you realize you cannot take a square root of minus 2/3. Let me check this. Yeah, and that's sort of bothersome. So I'm gonna graph this thing. Why? Yeah. So one of the reasons you always graph first, if you can, like if this were a real life situation, we would always graph the data so we know what to expect. And we would see that these don't intersect. So there's no solution.
Okay.
So you got lucky on that one. No more work to do on that one. So let's look at 22.
Okay.
Let me grab 22. Why I'm struggling so much. All right. So again, you have to add and subtract the equations. Just rewriting it so that you can kind of see everything in the order here.
Okay.
So this time we're going to subtract. So we've got y minus y, that's 0, equals minus 2x squared. X minus 2x is minus 1x. Minus 3 minus minus 2 is minus 1. So this you have to solve. I would recommend moving everything to the left to do that.
Okay.
So I'd like you to try solving it from here. Basically, you got to move everything left and use that factor by grouping that we just tried in the previous problem. While you're working on that, I'm going to make sure this actually has some decent answers.
X squared plus x.
This one does not have any solutions. Wow.
No solutions again?
Yeah, which I mean, you can see it from the graph here. So when you get to this line right here,
That's where I'm at, yeah.
Now that I've told you this, you can go find the discriminant, the b squared minus 4ac. Okay, and that'll tell you it's 1 squared minus 4 times 2 times 1,
Yeah,
which is negative. So there's no solution. Graphically, I'll snip that in here in a moment. You can see it just doesn't hit. All right, why don't you, well, we got to do a little manipulation there on that one. Okay, a couple things on 26 that you can do. You can always reorder the equations. So like if you really want the second one to be on top, you can make it on top. In fact, we probably ought to do that plus subtract the 5x. So we have y equals x squared minus 5x minus 2, and then that second equation like that. So what I'd like you to do is subtract the two equations and then solve from there. I'm going to look at these and hope that they give you a nice solution.
Okay.
Hooray. But this is there, and the solutions are not nice. So we'll, wow. Okay, so you end up getting 0 equals x squared minus 7x minus plus 5. Does that look right to you? Yeah, so this one you have to use quadratic formula on. So I'd like you to solve with quadratic formula, and then we'll talk about what to do.
Square root of b squared minus 4ac over 2a. So then -7 plus minus square root of 49 minus 4 times 1 is 4 times 5 is 20. 29 minus 20 over 2. And then -7 plus or minus square root 29 over 2. So I ended up with -7 plus minus square root of 29 over 2. Do I have to solve that out?
It should be +7.
Oh, it's negative b. Yeah.
Yeah.
Okay, no, it's positive 7.
And then let me just hang on. I want to graph what you just said. That'll be my fastest way here to answer you. Okay, so you said 7 plus the square root of 29 over 2. Okay, that is one of them. And the other one is, yeah. Okay, so this is great. Now, I'm not quite sure I know what your question is, but yeah, you do need to separate these. We'll talk about why in a moment. Okay, now we're going to go back to the equation y equals 2x minus 7. And you have to take each solution and put it in here for x. Now it looks worse than it really is. Let's go 7/2 plus square root of 29 over 2, comma, y equals 2 times 7/2 plus square root of 29 over 2, like that, minus 7. The 2's cancel. So you're left with 7 plus square root of 29 minus 7, which ends up being just the square root of 29. So your ordered pair for the first one is 7 over 2 plus square root of 29 over 2, comma, square root of 29. And if you're wondering if this always happens, yeah, it does. It actually works out nicely, amazingly.
Okay.
So the other one, 7/2 minus square root of 29 over 2. Same thing, you're putting that in for x, 7 over 2 minus square root of 29 over 2 minus 7. It's the same thing. You end up getting 7 minus square root of 29 minus 7, and you end up being left with just minus square root of 29. So your ordered pair is 7/2, 7/2 minus square root of 29 over 2, comma, minus square root of 29.
Okay.
So rather than going to your teacher and saying, well, we have to use the quadratic formula to solve this, just know that you might, and here's how you do it. And there's actually a pattern to the answers. It's maybe you won't remember the pattern, but you'll remember, oh yeah, like a lot of stuff cancels. It's not that bad. I can do that. I can do it. Okay, 28 is next. Is that right?
Yeah.
Error analysis. Goodness. Okay. All right. Again, we'll do it the way I recommend, which is we're going to take the original. Wait, are both 27 and 28 the error analysis? Oh, no, they're different. Okay. All right. So what I want you to do is solve this in any way you want, however you want, but I want you to solve it. Substitution, elimination, graphing, whatever you want.
Am I solving it? Or am I just looking for the problem for the answer?
I want you to solve it. This is just
Oh.
another chance for you to do a problem on your own.
Okay. It's 26, right?
Mm,
Or do we just do
oh, I'm
26?
sorry. I apologize. I totally apologize. You're on 20. We're going to come back to this one. We need to do 26. It's Friday night for me too. And I'm like, yeah, I don't remember. Oh, no, we just did 26.
We did?
Yes. Did we skip like 24 or something? Maybe we skipped 24. 26. Yeah, we skipped 24. Oops. All right, let's do 24.
Okay. Okay, so then negative x minus 2 equals x squared plus x plus 1. X squared.
So this one you do have to do the elimination. You have to subtract the equations again. Let me check to see if these work out nicely. Okay, go ahead and
Yeah, I got
Let-
x squared minus 1 equals 0.
when you subtract
Yeah,
the
yeah.
negative, you get 2, that it becomes positive x.
Oh,
It's Friday night for you too. We're a little shaky
yeah.
tonight. Okay, I want you to do the discriminant. That's your fastest path to know whether there is a solution or not. If there is a solution, maybe then you figure out how you want to go about
4
solving it.
minus 4 times 1. There's no solution.
There is no solution. That's right. Okay. Now on to the question I had envisioned us doing. Where is it? Okay, never mind.
27 or 28 should be.
We're gonna do 28 or 27. Which one do we have to do both?
I think we have to do, yeah, both.
All right. Well, that's good. Okay, so what I'd like you to do, just because I think this is really helpful, is to try solving this now. Any method you want. I mean, if you believe the graph on the right there, which there's actually no reason not to believe that graph, but you got to give me the solutions, and maybe there's more than one solution, or maybe there's only one.
Okay. X equals 0 and x equals 5 halves.
X equals 0 is correct, but the other one is not correct. Let's see what you did here. Did you use substitution or elimination? What did you use?
I did substitution.
Okay, so 2x plus 4 equals x squared minus 3x plus 4. Subtract 2x, subtract 2x, subtract 4, subtract 4. So notice that it's just x squared minus 5x. Is that what you
Yeah.
have? So when you factor out an x, it's x minus 5.
Oh, I did the divide by 2 and then square and all that.
Okay, yeah, when it's just got x's in it, you can do a GCF factoring. So I'd like you to,
Because where did I go wrong dividing? Because I divided it in half and I got x minus 5 halves squared equals 0.
no,
You got to square that so you can get x equals 25.
wait, are you saying you divided x squared minus 5x by 2?
Or just the 5x, b over negative b over 2a.
Okay, but you don't want to do that. Like that's to find the vertex. If you're trying to, are you using quadratic formula for this?
No, I did what we did last time and I divided B by 2.
You mean for completing the square?
Yeah,
Okay, you don't want to complete the square. The only time you'd complete the square is you'd have to have a, yeah, like,
third term.
okay, so let me answer your question though. It would be x minus 5/2 squared. So I don't want you to do this, but this is correct. You square both sides or square it so it's 25/4. Okay, I like the curiosity.
And then you take the square root of that.
Plus or minus, so it's x minus 5/2 equals plus or minus 5/2. Then you add the 5/2 to both sides.
Yeah, that's what I got.
So it's 5/2 plus 5/2. 5/2 minus 5/2.
Yeah, so you get 10/4 and 0.
Nope. Okay, there it is. When you're add, you keep the denominator. When you add fractions, you can only add them when they're the same denominator.
Okay.
So now can you go ahead and find the y values?
And 2x plus 4 is 0. And get 0 for one of the points, and then fucking 5, 10. And then 15, 5 and 15.
Try
Or
again.
5 and 14. Sorry.
Good. Very good. So the issue with what they have presented to you, and you know, it's good that you made another attempt to solve this. The graph is misleading. There's actually a really, and there's a lot of TED Talks on this, like how to mislead or lie with statistics. And you can do the same thing here with the graph. It almost looks like these things won't intersect because they haven't shown you where they intersect, but they sure do. You know, if you could extend them, they do intersect. So that is the error. The error is they intersect, but you only found 2 of them, or only one of them. When they only intersect one time, it always occurs as a tangent. A tangent kind of bounces. That's not very good. Kind of bounces off. That's a tangent. That's a tangent. It has to kind of bounce. It approaches and then doesn't approach.
Okay.
So whenever you see it cut through, you know that it's going to hit again, is the point.
Okay.
All right. For the next error analysis, you've already done it. Well, no.
Yeah, we can skip the next error analysis.
You sure? But they're so much fun.
Yeah.
Well, let me just make the quick. I'll just do it for you because I really want you to see that, you know, what happens here. You set the 4 equals 3x squared minus 6x plus 4. The 4's cancel. 3x squared minus 6x equals 0. Factor out of 3x, so this becomes x minus 2. What are the 2x values?
You get 2 and 0.
Yes, and then you go back, but in this case, the y value is always 4. So it's x equals 2, or x equals 0, y equals 4, x equals 2, y equals 4. You got it. All right. 48. Is that really right?
Yeah.
Okay. 48 says to solve 38 using elimination. So you have to use elimination.
And so minus x squared is x squared. Plus x.
And then that last one
Minus
becomes
3.
Yes, -3. So
Zero.
take a look at the discriminant first, see if that gives you a solution or not.
1 minus. Nope, no solution.
Wait, it's 1 squared minus 4 times 1 times -3. I get 13. Which isn't great, but it's not negative.
Oh, because the 4 is -2.
So this means it has a solution. Why don't you try quadratic formula on this one? The reason we wouldn't do completing the square is this middle one doesn't really divide in half well.
Plus minus square root of 13 over 2. So I got -1/2, -1/2 plus or minus the square root of 13 over 2. So then I'd put that back into the equation for x.
Well, let's you've got what is your, you got -1 plus or minus the square root of 13 over 2.
Yeah,
Okay, yeah, unfortunately to find y, you have to go back into this equation. So it's -1 plus square root of 13. Let's divide them both by 2 squared minus 5.
and you get 1/4.
You have to FOIL this. You cannot just square them. That will leave out terms. So -1/2 times -1/2 is 1/4. The outer is minus square root of 13 over 4. Yep, the inner is minus square root of 13 over 4. The last one is 13 over 4 minus 5. So these, and okay, so let's, well, I was going to say like to look at the pattern here, but let's just keep going. So it's 14 over 4 minus 5, which is 20 over 4. So it's minus square root of 13 over 2, because there's 2 of them over 4 gets you to the 2, minus 6 over 4, which is 3/2.
Okay.
To find the other one, the only difference
Is you
is,
make it negative.
yeah,
Would you just multiply everything that you got by a -1?
no, it's just the O and the I are affected. These, it becomes 1/4 plus square root of 13 over 4 plus square root of 13 over 4. This one's still 13 over 4 minus 5. So you end up getting the same thing over here, but it's square root of 13 over 2 plus, sorry, minus 3/2. Like that. And if you really want to check that, you can go in and
All right.
work that out.
Okay.
All right, so I know we got another lesson on Sunday. I can definitely provide some more nonlinear systems to solve if you want. That's kind of
Yeah.
up to you, but that'll do it for tonight for us.